Uh, my talk title is PG in AI applications. Reality is more complex than similarity search, right? So the cornerstone, of course, of any application nowadays when it comes to Postgres is doing a similarity search. But the bigger picture is usually the most difficult one. So we're going to do a bottoms from top to bottom approach here. So a bit, should this, sorry? This one?
No. This one.
Ah, in the middle? Okay.
Yeah.
Okay, thanks. Ah, sorry, thanks. Right. So a bit about me first. I come from a data engineering background. So I'm not that. Although I studied business initially, I shifted towards software engineering, and I work in core Postgres in JSON and full text search, mainly JSON to be honest. But my background comes from business analytics and business application, and that's why I use PG Postgres in more in the bigger sense of things. I first came to Postgres mainly through extensions. So maybe you've seen some extensions of mine around, like probably PGPDF, when I know this was one popular monstrosity in China. Another interesting extension maybe that you want to have a look at is this SPAT. Has anyone seen the SPAT? Right. It's an extension that should not exist in that it works, it basically gets a Redis-like API interface, but instead of basing it on, building it on main memory, it is based on main memory in Postgres, call me share memory, right? So what usually you use for shared buffers and whatnot, you use it for key value implementations. That's an awful thing to do, but it turns out it is a useful thing to do sometimes. Then PGJQ, it is what it sounds like. So basically you can do it like along with JSON path and JSONB, you can use JQ syntax with JSON path if you're into that sort of thing. And if you're into analytic stuff, I have ASCO and PGXC which is, in standard Postgres, you have correlation, you have the basic Pearson correlation coefficient, right, which is only detects linear associations. However, there are a bunch of other algorithms that can detect nonlinear associations as well, which here, like the X correlation coefficient, which is a statistic that we got a couple of, I think 3 or 4 years ago. It's very powerful, and some other one relating in the Vasco extension. So that is to say, I come not like from a hardcore programming background, but from a business and data engineering application background down to Postgres. And now on core Postgres, I work with SQL and JSON path. We managed to get merged for PG19 a feature set that I think will be tremendously useful for JSON path operations going forward, which is like chained text processing methods in PG19. Did anyone see that? Right, so basically in JSON path you can do some basic regular expression filters within JSON path, right? Now with, I should have put the patch here. With this patch I wrote, basically you can do blah 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 in JSON path, string, dot replace, dot uppercase, dot lower, dot split part. So you can do this type of fluent programming, as we say. It's very, very useful. Now, so going back to the demo, the AI in application, usually when it comes to every new interesting technology and very influential technology, you fall into the demo trap, which says, okay, here's my hello world example, and after the hello world, all hell breaks loose, right? So you don't really see all the implications of what happens after the creation extension. So the demo trap ignores high concurrency. So what if you have very high throughput in your data, and then your data changes, your load changes as well, and you try to implement to get the embedding computation on the fly, right? And of course, this is way more complicated than having to read a lot of data in the OLAP scenario. How do you handle data drift, right? So from a business perspective, you try to get similarity between comments and users, right? If you try to quantify the relationship between two users based on their comments, if they are very, very highly actively, right, on your platform, how do you track the changes? When do you recalculate the embeddings, the scores? Then, of course, you have disk bloat. A bigger recurring theme you'll see along with the presentation is that we have there's something new happening that with the standard way we do data modeling, we rely a lot on relational modeling. We have like foreign keys, primary keys, and so on. What we have noticed with AI applications is that we have a shitload of copy-pasting text around, because you have your base document, then you have different chunks of it, and then you split those two chunks, and then you get one embedding based on one version of the chunk, and then you change this again, you get another embedding. So you see a lot of data duplication going around. And most importantly, you have like a RAG frameworks like Llama Index and all these things that they don't really care about relational modeling. So they approach the database as just a bucket to store data. So if you want to do analytics on that, you're kind of left alone. And of course, the real challenge comes to putting all of this together in terms of having the pipeline for A to B. If your main data store is along with your analytical data store, that's even more complicated. You have to have operations like from monitoring and so on. And most importantly is how do you handle the data lifecycle? When your data gets outdated, what do you do then? So from my perspective, and I think this boils down to the recurring thing that we see nowadays, which is like just use Postgres, right? Personally, I've been a proponent of this for a few years now. And then all of my approach is how to facilitate doing this, like approaching PG not only as a database, but really as an orchestration layer between many different things. So the first take I want from here is like start treating Postgres as a storage bucket, right? It's very powerful, for typical analytical stuff. Even though people say that, Postgres is not that powerful for lab analytics, let's be honest about it. When it comes to AI, we don't see that many multi-join tables around. You have one or two maybe joins, and then maybe your problem is that your tuples, your rows are maybe wide. You have some indexes that don't really work because you have outdated statistics and so on. But the limitations of the query optimizer, one might say, I don't think they are obvious here. Of course, there are some limitations when it comes to buffer size and if you're doing like a lot of embeddings and so on, but I think that's secondary. The bigger thing that, of course, you have like asset compliance, which is a given. People, especially on the first wave of analytics, people that were, you remember, I'm sure, that everyone was just dumping files, they would do embeddings, chunking, and they would have intermediate files through the disk, right? So you have like even non-hello world scenarios from Llama Index and all these tools, like running their examples and spitting files on disk. Of course, you don't have asset compliance there, right? One important thing that was not immediately obvious as necessary in the first steps of RAG was role-level security, or like multi-tenancy in the similar kind of way. Is anyone involved in a scenario where you have RLS requirements or multi-tenant requirements? Right, so we'll speak about this in a bit, but it's very important. And then, of course, in Postgres, you can have logic as well, right? And logic not only in complicated queries in PLPG SQL. I want to emphasize this again and again. Postgres is very powerful as a DSL host, as a domain-specific language host, because really, JSON path is a DSL, right? I mean, the previous presentation was really great. I'm not sure the guy is around here, but the fact that he had built, we were seeing a mini DSL of linear algebra operations in Postgres, it's tremendously powerful, right? Because you have very rich syntax, and you can do very rich computations in many condensed characters. Similarly, I can say that even the PG vector operations, they are a sort of DSL on their own, right? Because you can express a lot of mathematical computation into succinct operators. Of course, it's a single source of truth, of course, the database, and from my perspective, you should store as more data as possible there, and that is why probably the most profound success of Postgres in that regard, in that it tried to, now have your whole relational business model along with your vectors and the embeddings. And of course, this is a theme that I come back to again and again, like data engineering has digressed a lot, and you can see most of the tools or data platforms going around, they reinvent a lot of things. Whereas someone is a very, allow me to say, someone maybe a bit above average of a Postgres PG user or like query builder or whatever, they can do most of this stuff themselves. The pieces are already there in the documentation if you look for them. So in data engineering, there are a lot of unnecessary complexity going around. So first of all, let's start with the asynchronous ingestion pipeline. This is basically the cornerstone of any AI application. You have some data, but you have to calculate the embeddings of them, right? There have been, and personally I even tried this myself, some ways of trying to compute the embeddings within database. You could think like PGAI and a few other tools. From my perspective, I never really got them to work because it's still an operation that you can have like timeout errors from your API, right? You can't rely on having this within your query execution context. You have to have an external service that you try to compute the embedding, hit an external API, write to the database. If it times out, cut it some slack, like sleep for a few seconds your script, then try again. You cannot really do this in the database in a nice way, or a convenient way, as I might say. So expenses are expensive mainly not in terms of cost, right, but in terms of network overhead and even disk overhead, copying data around. You have to copy data from a database over the network and back again. What happens when synchronous generation fails? So you have to have timeouts. Of course, you cannot have like cascading failures. Like if you can't really have you can have a not null constraint on an embedding to not be null, but if it is null for one execution, you can suddenly drop any other row that relies on this, just because you have a new version of the embedding. So the solution here is like you decouple your document intake from the vector generation using Q. So you have like your documents in one table, you have some external service that you rely to get the embeddings, and you have another table to build to store the embeddings. So how do you build a high-performance job queue? That's a very fundamental operation. People have been trying to implement this for decades. Like you have, like a few years ago, we had, decades ago even, we had a RabbitMQ. Then we have Kafka, which is not really job queue, but it can be used for that sort. You have Redis and so on. RQ, which is a Redis queue, another. Many solutions. From my experience, the cleanest solution one can get is like using the skipped locked pattern. Has anyone used skipped locked? No, that's, I think we'll see an example of it. So basically, it's like how the question is how you have, if you have a big table and you have 50 different workers that are trying to fetch data from the same table, how do you sort lock contention, let's say, from reading between multiple workers? So you have like, if you have like 100 rows, the first worker will try to read from one, the second will only have visible only the 99 rest of the rows. This is not an easy thing to do, but since I think 14, I think was it, PG14, we have the update skip locked. Let's see an example of it. So we have here a table, embeddings, where status is pending, and then notice this is in a bash script. So this is an SQL query, right, but piped into a script. Has anyone used a pattern like this before? Yeah, so this is very powerful. I'm telling you that these 4 or 5, how they are, let me see. Yeah, they are 4 words. These 4 words, they can actually blow out of the water any other queuing solution you might need. Why? Because it says, okay, try to ping this for a tool, and then you can even parallelize this, and then the for updates keep locked. Make sure that out of these 10 workers, they never see the same piece of the code again. So, so whenever you try to for loop of it, each worker sees available only the rows that are not picked by another worker already. And I assure you that if you do a lot of patterns like this without having the same, without using update skip locked, if it works, you're probably lucky that it works. And if it doesn't and it fails for some scenarios, you probably haven't noticed it. So that's one neat example of that one. And by the way, be sure that most of the tools that I have seen around, like Llama Index and LangChain, on the previous version of at least, they did not handle this gracefully as you'd expect, because they were trying to handle parallelization. They would have like an argument of max parallel workers, but if you see the underlying implementation, it's not really that enough sufficient. So how do you handle them? How do you manage the data lifecycle? From our perspective in AI applications, this is the most tricky thing, is that data, it is useful, you calculate some embeddings, then your data changes, and now even the more interesting thing, not only the data changes, but the models change as well. So if you have some comments and you have some content, you embed it with Gemini, I don't know, 001 preview or whatever, and then you have suddenly 001 flashlight or whatever for embeddings that are not flashlight, but you get my idea. How do you handle multiple versions, right? And then embedding models, maybe they're near free now, but how do you actually decide on when to re-embed and when not to re-embed? Are all the users equally, are all your documents equally important to spend money on? These are tricky questions to answer. So what happens when a document changes? The cost of re-embed everything. And keep in mind that up until now, a lot of like LLM models and generative models and embedding models, they are kind of like the first steps we had on the cloud era. Like everyone was giving free credits away, so you got to spin like 10 or 20 servers, which were they were very cheap, but then suddenly the prices went up. I assume we'll have to get into another similar scenario here as well, right? And then how do you change, okay, LLMs have a problem that your question is, famously, they would assign more importance to the first part of the document, like the abstract or the intro, and maybe ignore the part. So what we will do is split the document in chunks, try to recalculate the changes, and if something changes, rerun it again. How do you handle that? So there are some special scenarios that you can use, like hashing, like chunking and hashing. This is the RAG frameworks. This is how they used to do it, but you can do it yourself in Postgres as well, and to detect how much difference there were in there. So one recipe is multi-level hashing. I won't get too much level into it for now because it's a bit advanced, maybe out of scope for now. So you basically hash the file or the page that you want and see how much it changed after the fact. And of course, you should always keep in mind storing metadata along with your files. And my advice in there is that try to shove all your metadata not in columns. Put them in a JSON-B document. Don't rely on having like a timestamp column with time zone, or then a model version or whatever, because you cannot really reason in a relational way in this because they change a lot. So instead rely on a metadata design column. This is my favorite, probably one of my favorite features of Postgres. Who knows about tablespace? Have you ever used them? No. So one of the initial, very popular pitfall with in Postgres is that you can very easily get out of disk space. And it used to be the case that you store your data, you duplicate a lot of data, and in a previous era where disk was a bit, disks are there, like, especially SSD ones, they were much smaller. It was very easy to run out of disk, right? So people would say that, oh, my Postgres is broken, I need to upgrade or whatever. In fact, table spaces allows you to define to split your storage layer, be a lot smarter about it. So you can say, okay, this is my main disk, like 200 gigabytes or whatever, and then you can plug external disks And most importantly, you can say that this is called the table space. So your PG data, you have your main one, and then you can say, oh, I know this table will store a lot of data, right? So what do I do there? I plug maybe even a simple disk, an external disk, just for this table, create a table space of it, and store it there. This simplifies your architecture quite a lot. And you can even be even smarter about it, and instead, you can have a faster disk serving this particular table, or a slower or a cheaper one. You can toggle this and be smarter about it. So vector data is huge. You cannot, you don't want anything like even your cold data, as we say. Like as long as you have executed your embeddings, you don't really, probably don't need, and you have your summaries already. If you have your raw data, your raw document, probably you'll never read it again unless you calculate the summary or the embedding. So you can have your cold data, the original document, into slow or cheaper disk, and you can have your embeddings, which you want for PG Vector to be fast about. You have your embeddings and your summaries in the faster disk, right? This is a very efficient recipe. So yeah, so typical example with partitions, that is, right? Here we see an example. Notice that, let's say this, the documents here, it's our cold data. We insert them, and then it's our raw data if you want. And then you say, okay, I'm running out of disk space, right? So what I'm going to do is I mount another disk, a faster one, whatever. I create a table space, and now for the table that will store the AI, whatever, the vectors and the summaries for this one, which I want to be fast, I will create a document chunks table, which is my normal schema, but I will say to use this table space that I used, that I defined here, right? So if someone asks if you are the DBA, and they say that, okay, can you pinpoint me where my data is? Then you say that this data is somewhere in your use lib, blah, blah, where your PG data is, and this will be in another disk or directory. So this is pretty neat and to work with. Another very useful feature is usually like partial indexes, right? So you can have indexes over only a subset of the data. This is not something really new, but you can have like you can build very nice scenarios in there, not only for performance purposes, but even for semantic purposes. And you can even be smarter about it and supposedly say you can even have indexes semantic, like assume, for example, that I store comments of whatever platform, right? Let's say I store comments from LinkedIn, right? You have indexes based on when these comments were posted, who posted them, or whatever, right? You can even have indexes, though, right, based on semantic meaning. So you can say, instead of calculating when the comment was created, you can say, keep me related, only create me partial index on the comments who are semantically closer to Postgres. So what will happen at insert time is you will get the embedding value for the comment like PostgreSQL or database, and then you will calculate that distance for every comment on write time. And then whenever you read it, you'll have ready the analytical query there. Partitioning is I think it's a very popular feature. We have it for decades. Personally, I never liked partitions that much. They are very easy to forget, creative partitions. So every January 1st or year change, someone loses their job, or they should lose their job or whatever, because the cron job didn't work or so on. So it's a tricky, but it's a necessary evil, to be honest. You can, of course, partition by date, region, or tenant, and you can reduce your spaces quite a lot if you prune based, again, on the hot and cold data split that we saw earlier. This is security and multi-tenancy. So what, very simple words, what multi-tenancy is that when I want to do analytics or RAG or, how is it? I can see what that says. 10 minutes, okay. Okay. See? You have to decode it for me. Right, so what does multi-tenancy means, right? It means that if I have multiple customers for my eShop or whatever, I could theoretically, obviously I don't want to see the rows and tables that each customer has, each other customer have when they SQL queries. Yes, what you can do is you can theoretically first, you can say, okay, I will just copy paste the database and have a different database for each customer, right? Well, good luck handling that. So what multi-tenancy means is that you can use the same database and the same table, but be able to serve multiple customers without relying on application level handling of this. So otherwise, if you didn't have row level security, as we say, you'd have to say from the application side, okay, who's the client asking for this one? Then whatever query you do, just plug another predicate where client ID is this or that. You could do that, but it's very cumbersome, very, very complex, and especially very easy to make mistakes on. You don't want to see what sensitive data one customer has if someone else does the mistake there. So Postgres implements this with enabling row-level security. So mainly this comes. So this mainly comes very very useful in RAG complex scenarios. In that you obviously don't want to for DeepSeek or ChatGPT to base your questions on I don't know on MySQL based on what I ask for in Postgres. So how do they handle that? How do they do like these RAG, let's say, operations in a way that they don't change their queries that much, but B, you don't have data leakage from customer A to customer B. The easiest and standardized way to do this in Postgres, and this has not been a discussion that has been happening as much as it should have in RAG cycles, but now it's becoming a reality. You can enable row-level security. It has been around for quite some time, right, to be honest. So how would you do that? Is that, okay, blah, blah, create extension vector, and then you have your knowledge chunks, and then you will say that alter table. It's the second time I do this conference. It's the second time I do the same mistake. I should have known that it goes up to the bottom. I should have put it like a bit higher. So, and then you can say, okay, alter table. You should enable row-level security. You should force row-level security for the whole table. And I think I have the example here. So from the application perspective, you should create a policy, initiate and specify the current tenant ID, which it says it is the connecting point between database and application level, right? And then whenever a query, whenever the database expects a query from the application level, that query should also, as a session variable mainly, you should have this current tenant ID, so the database internally knows who is using that data. So it basically behind the scenes is sort of a view, like a limited view of that data. So if you have like a PsychoPG query here, you set a local variable like current tenant ID, which is your authenticated tenant ID, right? And then you don't pollute anything in your query about it, but the database does it for you. What would be the alternative here? Instead of having the tenant ID as a local variable, you would really, I've seen people do that. It's not that wrong. It's that you just concatenate another class where tenant ID is this. But this is very easy to make a mistake for. So why this is really interesting here is that you don't want to have like leakage not only on after trained, but even pre-trained data on between multiple tenants of your database. Transactional integrity is something that we take as the given, but it's because people rely on a lot of intermediate flat files and JSON files and so on. It's important to underline that having your transactional integrity it is a given if you use SQL, but if your pipeline is not 100% ASIC compliant, even in one small part of it, like, I don't know, generating summaries intermediately and then split into disk and then copying profile to the database, even if one part of this fails, then your whole pipeline fails. So the typical scenario is that the row says no because the index has not been, the buffer has not pruned already. How do you handle long-running transactions? These are very tricky point for Postgres has been, probably will also be for years to go. How do you handle long-running or even idle transactions from seeing that data that are not there or have a previous value or have not been embedded or so on. So hybrid query power, and this is my favorite approach. I think the most important takeout from this presentation and from the general aspect of things when it comes to this is that we do search we can do search in three ways. The first one is SQL, because from one perspective, running SQL queries, it is sometimes some kind of search, right? It's very rigid, and very specific, and very not fuzzy, but it is one type of search. The second scenario is what we do like full text search, right? You will see an example, but full text search basically it's very simplistic that relies on stems and prefix and so on. So as long as if you run FTS, Athens in Georgia and Athens in Greece, they're basically the same thing. Well, if, however, you run a semantic search, they're completely different things. So let's see. So the power here is that, from my perspective, is how do you handle vectors and full text search and JSONB? Because I have a patch for PG. We didn't manage to merge this in PG19. I hope we will do to merge it in PG20. I have a submission there. I should have put a query here as an example. Anyway, if you anywhere links around the commit fest app around here? No, you should. Too bad. Okay. So I haven't. Anyone used full text search like TS vector, TS query? You have, right? So TS match is basically an operation that I derived basically. To be honest, I didn't see it anywhere else. That says we can have full text search within JSON path. So within JSON path, you can have like a string created TS vector, and also have another JSON path element basically injected from an external, let's say, query, or from outside the JSON path, and you can do full text search within JSON. It's pretty cool. And if you also think it is so cool that should be in PG20, you should go to the commit fest app, you should support or even review, right? Okay, so let's see an example here, for example. So the first part is that, let's say we have our products, and we do our semantic search, right? So what is the bigger story is that we don't want to do only semantic search on only full text search, but we want to combine these two. And remember, in SQL, in a language like SQL, we see whether or not this row satisfies this predicate or not. So it's a 0-1 thing, right? Well, life is a bit more complicated. So you have scores. So in full text search, for example, you have score. Like you can say this text, this query matches this vector, but you also have to say it matches it with a score of 0.56 or whatever. The same applies with embeddings as well. So you have a score of embeddings, how close they are. And the name of the game is how do you combine those two. So let's say we start with the semantic search of it. So we search from products. Notice here it's a hard index satisfied or not, so it's a true Boolean. And then we can say that for products where the embedding, which I have already calculated, is pretty close to this particular vector. I don't know, that's a random example, right? And then you have how close this one is, you order by. You have this window function there to row number, and you have a window of the most relevant products in top. So you have the vector rank of each product. So this is the one part so the semantic search part. This is one common table expression. And then you can have the full text search part, so we put this into one bucket. And then you have another keyword search that says, okay, do the same thing, right? But then you do also the same filter, metadata fetches or whatever. But then instead of doing an embedding distance search here, you should say that find me the the products that their description matches wireless noise cancelling headphones, right? So you get another score here. So the row number here is another, the FTS rank is another score that you get there. And then you should combine those two in the third step in a way that is called reciprocal. It's called RRF, reciprocal rank fusion. So you basically compare. It's a very it's becoming quite popular as a formula which combines those two in a way like that we see like this here. So you don't really want to see, and I think you get the idea why you don't want to relate only on semantic search or only on full text search, because in our case, the full text search could be, it's too generic in that case if you have many headphones. But it's even more obvious in not that clear examples. Notice here that we have a full outer join, because we say that the semantic search is, should also be there, and maybe the keyword if it matches, it should also help but not impede the score calculation. And I think that's it. Thank you so much.
Okay.
I hope you enjoyed
Thank
it.
you.